So on this portion of the tutorials, we will be modifying the power strip. We have to modify the power strip because the microbit that we're using is, it only operates in DC current. And our power that's coming in, and most of our electronics, the pump and the light, are AC power sources. I'll put a link to explain the differences between those two. But for this portion, what we're going to need is the small screwdriver set, your wire that you have. It's probably already cut. You're going to need your box or your box of connectors, and these are easy solder connectors. We're going to use our heat gun as well. I have the drill because I use this along with this to make unscrewing and rescrewing in back easier, but you're fine to just use the small screwdriver set. I also have a marker and these little sticky dots. These were not included, but I found it's easier to label things. So if you have any stickers or something, it will be helpful in this stuff. So if you just want to use tape, any of that's fine. Which, speaking of, I need to grab some tape. So I will grab that as well. And then our wire cutters. So this is everything that you need. I'm going to pause real quick to grab that tape, and I'll be right back. Oh, never mind. I have it right here. So first thing that we're going to do is we're going to need to open up our outlet or our power strip. And to do that, I'm going to go ahead and remove everything and then just focus on this. Like I said, I like using the drill. I will show both ways, just so it is easy to do. I'm also going to, let's see, let me use the tape. Since you guys probably have tape and you probably don't have the little color dots, the tape will probably be easier to use. So, let's see. Pull this piece of tape. So the first thing I'm doing again is labeling, just basically numbering my outlets so I know which ones are which. So I have that tape. I'm going to put it right here. Tear. And so I'm going to number these left to right. 1, 2, 3, 4. I'm going to go ahead and label 5 and 6. Those will actually remain always on, so we'll actually plug our microbit into 5 and 6 just to use as an always on, and then 1 through 4 we're actually going to make it so our microbit controls the switches, and then these switches will actually not work anymore. We're not going to be taking them out, we'll just leave them there, but that's first up. So label, and now ship these out of the way, as well as this. And so I found the easiest way to take this apart where we need to take it apart. On the sides, there are 4 screws, and you'll see on both sides. What we want to do is flip it over so the outlet's face down. We have a black part right here. And I'm going to need to remove one side, not the cord side, and then remove these screws on the cord side. So we're going to start with this side, removing all 4 screws, because we do need to take this piece off, and then we'll set that aside. So, like I said, you can use your small screwdriver set. It is a nice, what is this? Oh, it just spins. Nice little way to do it. I did find some of these screws to be a little bit challenging to get off. So I'm using a Phillips head screwdriver, and I'm going to be unscrewing these screws. I'm going to zoom in just a tiny bit to make sure we can see what I'm doing here. Okay. So we're zoomed in. Like I said, these screws are right here. We do, again, want to remove the side that does not have the cord. So cord. I'm going to remove the screws on this side. And lefty loosey, righty tighty. So first one. Oh no. I need a different. Yep. Sorry. My Phillips bit was too small, so I'm moving up to larger size here. I want to strip that screw, and there we go. Lefty loosey. And these will just fall right out, or they should. Maybe they don't. So I'm going to go ahead and remove the other two. This is why I like using the drill. Oof, there we go. Sometimes they can be in there a little tight. Same thing on this one. There we go. And so now this cap will come right off. I do have all the 4 screws there. Tip it out just so you can see. Those 4, this one's in there. There we go. So 4 screws, cap. Now we're going to need to only do the bottom 2 screws, not the top 2 screws on this one. You can do the top 2, but it will not do anything. Alright, so I'm making this video after I found that the camera had glitched and missed an important part of the tutorial. Previously we were taken off the side here. There are wires sticking out. Ignore those for now. We're just going to go through what you're going to see inside here. And also, so we've taken the bottom 2 screws off here and here if you used your drill or your screwdriver, either way. And all this bottom part will do is just slide. So we're just going to slide that right off, and that exposes the underside of our power switch. Now, as I mentioned, it's a good idea for us to label things. You do see we have our labels here. It's probably upside down to you, but we have 1, 2, 3, 4, 5, and 6. What I did on the underside for each outlet is I also labeled. So 1, 2, 3, 4, 5, and 6. You may have the yellow version of this outlet, and that's okay. I did a poor job of labeling this one, but if I were to go back and do it, I would just label with a Sharpie right directly on this yellow outlet bottom. Completely up to you. For this black one, I did use tape, and that's what we have here. So we have our taped numbers, and we are ready to begin. In the next portion of the video, I talk about cutting these middle parts so we can be able to label, wire our black wires into them. Right, so in this next step, what we're going to be doing is interrupting this outlet, this circuit, so we can control it with our microbit. Again, I've already done this part because the camera didn't record correctly before. But what I explained in that portion was what we have going on here, starting at our AC power side, and I'll post a link to the difference between AC and DC voltage or electricity, is we have coming in from our house, our main power source, we have 3 wires. So we have a black wire, which is typically our hot wire or our load. And so we have a white wire, which is our neutral, and then we have our green wire, which is our ground. When we complete a circuit, we have electricity supplied, and we are using switches on this outlet to interrupt each circuit. So when it is at the O, that's an off. When it's at the 1, it's an on. And so we're basically taking this part out of the equation. And to do that, what we're going to do is, and you see here, we'll look at 1, 2, and 3. We're only doing this with 1, 2, 3, and 4. Those are going to be the outlets that we will control using our microbit. We will leave 5 and 6 always to be on, or actually to be controlled still with these switches. We just do not need all of the switches to do that. So how we are going to go about doing that is we are starting at 1, going to take this middle wire, and before I'd cut it, the middle wire was connected to this wire here, and this wire and that middle wire were basically connected together. Let me get that in a better shot. So again, this little nub that I have on that middle lead for 1 on the switch is the part that was connected to this part beforehand. And so what I did was cutting it, and in the next portion you'll see I'm going to use this insulated wrap to solder the wire that's going to be cut to the small wire that I've cut here. And so I'm going to do that for 1, 2, 3, and 4, and we'll go through that part in the next part. Where I pick up in the next video is taking my wire cutters, which are right here, my wire cutters, and I'm going to use the part that is the sharp part here to cut the copper wires. So I'll pick up in this video next of wiggling the copper wire or the wire cutters under that wire and then cutting it. And so when I pick up, I cut 1, 2, 3, and 4. I'm leaving the middle on 5 and 6. And you'll notice I do cut this end one here, but that's going to be for another video. Cut that middle again. That's 2. This is 3. And this will be 4. Can wedge that in. There we go. All right. So I again have my black wires coming off the main outlets. I have the rest of the portion right here inside, and if you want to wiggle those around, the leftover bit, see if you can get it off. If you can't, it's okay. We can tuck it, or just making sure it doesn't touch another lead. So just turn those in there. And again, if you have some pliers or something that you could cut those with a little bit better, that would be good. If you don't, that's understandable and it's okay. So next thing I'm going to do is take these wires that I cut, the ones that I didn't just tuck, and I'm going to take the wire strippers and strip the wire. We do this so we can expose the copper wire actually inside. So the copper wire is what conducts the electricity. The plastic or rubber vinyl coating on the outside is just what protects it and protects us, quite frankly. So, all right. So I've zoomed in and repositioned the camera just so it's a little easier. First time making a tutorial, so especially with small electronics. So this is a new thing for me. I'm learning, and I hope this is helpful. I will provide like a just instructional video for stripping wire. So what I'm going to do is again go strip these wires. Now, if you notice on your wire strippers, you have different numbers on the sides here. This is a stranded wire, meaning that it's not solid. There's a bunch of little copper wires inside these wires, and so what we're going to need to do is choose basically the right number, which I think it's 18, if I'm not mistaken, or 16. And I probably should have tested that before, but let's see. So stranded, I'm going to start with 16. We'll see what that does. Okay, 16 worked. We'll just stick with 16 Or is it 12? Let's see. Yep, I think 16 is going to be better. Alright, so what I'm doing is I wanted to test and see. I'm using the wire stripper and basically going and putting the wire in the valley of where the 16 is on the strand side. Okay, so strand side here, 16 is in that valley. I'm going to then close these, and sometimes you can rotate it and it kind of cuts it, but ultimately you're going to pull that plastic part off and expose the copper wire. You don't need very much. I'd say probably a finger's width, which looks like about a ½ inch. So we're going to do that for each of the ones that we cut. So that's 1, 2, 3, and 4. Again, going into that valley of 16. All right, clamp the teeth down and then pop it right off. Same thing on this last one. Pop and bam. There we go. All right. So we now have 4 exposed wires on our black components or black wires here. Now, what we do need is the we're going to use these, which I've found are really great. I'm not really good at soldering, and again, soldering is basically connecting 2 pieces of metal together by heating a piece of softer metal, usually silver or lead, to basically bind them together. I've found this kit that is very easy to use and very, very neat, I think, because of the fact that it's so easy to use. I was going to say blue, but I think we could use red. I'm going to test this real quick. So typically after you cut stranded wire, no matter what you're going to do next, you're probably going to want to twist that end. So what I did is basically made it from all the little things separate, like this one, where it's like a fan or like a broom, and I've just twisted them together just so they stay together. Be a lot easier to manage them. I'm going to do that with each one real quick. And then I used blue on the last ones, blue of this little heat solder wrap thing. But I'm wondering if red's going to work. And it's just the size. As you can see, the reds are a little smaller and the blues are a little bit bigger. And to be honest, I don't think the red, well, all right, there we go. Let me test the other one real quick. And nope. It does fit that side. And okay, we're just gonna go with blue. It's gonna be easier. We don't have any of those slight issues. All right, so let's grab out 4 blue connector solder things. Let's see if they have an official name here. Wire strip insulator thing. So we'll go with that. And so we're going to take 4 of those blue ones, set them to the side, and we are going to use, let's see, red, because black would be great. Okay, so we're going to use red cable for this first one. So in AC current, typically black means power, but we are switching to DC current. So let's, trying to think, I guess it's probably not that big of a concern either way. So my brain's not making decisions. Okay, let's do black, just to remain consistent, and we'll make it a little easier on ourselves. So we got our black wire here. Sorry, I'm out of camera. Black wire. I'm going to zoom out slightly. Ooh, there we go. We have our black wire here, and what I'm going to end up doing is connecting these two, and then using the solder strip thing to bind them together. First thing I got to do though is measure out my cable and make cuts. So I think it's better to overdo here rather than underdo. So if you have too much cable, that's fine. We can always trim back. If you cut your cable too short, that's going to make it more challenging. So I'm just going to measure. All right, zooming out just to show the heat gun here, and it has a little shield. It's actually pretty nice to put the piece that we're using inside, like scooping it in, because that keeps our heat closer to our solder because we need it to get pretty hot pretty fast. But we don't want it to actually rest on the metal part. It may actually stick to that metal shield. So I'm gonna move that kind of close. Now, this is hot. This is a heat gun. It produces heat and pretty hot heat. So it will burn you if you do not pay attention. So make sure you pay attention. Also, I'm gonna take this out real quick. We have our switches here, 1 and 2. 2. 1. 2 will, I'm guessing, produce more heat faster, or I heard the difference in the fan motor, so maybe it's just producing less heat. I don't know. I usually go to 2 and just wait for it to melt. So again, we're going to scoop that in there and turn it on. Oops. Let me zoom in so we can see what's going on. Oh, zoom in. And let me get that positioned right here. And we will get this going. I do move it back and forth along so that way everything kind of heats evenly. And whenever you see some silver leak out, which it looks like it has, go ahead and turn that off. Carefully take this. It has a little stand that you can prop it up somewhere so you don't burn yourself or burn something else. And this is very hot. Don't touch this, but I did want to make sure it did melt. They say to leave it for, I think, about 15 seconds or so. But you can see the insulation wrapped to the wire, and it actually started melting a little bit of the black over here, so I probably had it a little too high, and that's okay. So, oh, you guys can't see that. So probably a little bit too much heat in this area. I'll probably try it at 1 next time, just to make sure I don't melt everything. All right, so let me reposition here. Hot. And next I'm going to take the second shortest wire that I had cut. We're going to do the same thing. So we're going to twist the ends and twist the end here. I'm going to loop them together. And go ahead and pass down that blue thing on the other end. Figure it's easier to do it this way. And run it all the way down there so it covers up our copper. And now I'm going to go back. I'm going to do 1 because that 2 got pretty hot pretty fast. So let me see if I can get this in camera. It might be a little challenging. You do it the easiest way you can. I'm going to do it so I can hopefully show you guys. You can also back this shield off a little bit too. There we go. All right. To 1. And Okay, good, got it. This one a little bit easier to see, and my black rubber did not melt as much, but the silver flowed down into the copper and connected the two. So there might not be. There we go. Might be able to be seen that way. All right. So I'm going to go ahead and do that to the other ones. I'm not really going to talk while doing it because it's just easier to go ahead and knock them out. But we want to go ahead and do 3 and 4 the same way with the third shortest and then ultimately the longest. So here we go. 3, wrap these together. And honestly, I'm going to go ahead and wrap these together. Okay. All right, so we're going to need to do one more cut and solder before we put the bottom part back on. So we're going to go, and basically what's happening is this, to complete the circuit, this black wire that's coming from the main power in your house is supplying each of these switches with power. And when the circuit here gets connected between the two black lines, the outlet gets power. That's how the switches work. What we did is we said, well, we're going to take this switch and we're going to make it our own. And that's why we removed the middle, because the middle on this 3-prong switch is where the power interrupted basically goes. So what we're going to need to do is we want basically 5 and 6 to keep their power, so they're always going to be on. And so I'm not going to take that other one. But what I am going to do, if you notice on all the thirds, they're connected to each other. They're all soldered together. We're going in this video, this is a continuation from the last video. The last video was cut off, and so a lot of this has already been done from what was previously done. But we'll pick up. I was counting the third leads that were from each outlet, and what we were going to do is from the fourth outlet, the outlet we labeled 4, we cut that lead or that wire, which is this black wire here, that's now I've attached to a red wire. What I was explaining was that is supplying each of the outlets with power. And so when the switch is turned on for each outlet, it connects the circuit and the outlet receives power. By cutting the wire on 4, the black wire that connected 4 to 5, we basically stopped the switch from working completely. So that was supplying the power the full time. The middle lead was what the switch controlled, And so now each of these switches, again, don't work. We've wired them so they will work here, and we're just taking the power from this. And so what I did is I took that one that I cut off of 4, and I used the solder and the heat gun and attached it to attached it to a red wire. And so the red wire, I then stripped both ends, and I have that as what I will use for my power. The last thing that was done, just so we can make sure we keep up with it, is I labeled each of the wires that we have coming out. I did this because we're about to close this back up, and we want to make sure that we keep up with which wire connects to which outlet. The power is different. It doesn't need labeling. We labeled it by choosing red as the color. So what I'm going to do next, after I've labeled each of these wires, and again, how we label is I'm just tracing from here, that wire that I connected, and I just put a 1 on there, which matches 1 here. Same thing with 2. 2 is coming from here, this one from here, and I've labeled it 2. How I handled some cable management is I just tucked the wires in this channel between. So starting with that furthest away one, or one that's farthest back here, 4, I tucked that wire first, and then I tucked 3, then I tucked 2, and then 1 is not really needed to be tucked. It's right on the end here. I have my red. What I am going to do is I'm going to take my drill, and I'm going to drill a hole into my cap that's going to go back onto the outlet. The reason I'm going to do that is so I can run my wires out of that cap and make it so we don't have that side exposed. So I'm going to switch drill bits back to my step bit, not the one that I was using, and that will be pretty much the last step in this process. I'm going to go ahead and pause while I get that switched out, and I'll be right back. Alright, now that we're back, I'm going to take my drill that has the step bit on it, and directly in the middle of my cap, and if you need to put a dot with a marker, you can. I'm going to go ahead and do that. We're going to drill a hole, and I'm going to go and start with 3/8. I don't want to go too large, because if you look on the back side, there are these plastic supports here, and I'd rather not damage those. It's not going to make too big of a difference, but just trying to keep less mess is better. So I'm going to start going 3/8. That's about 3 rungs down. And that is thick. We're just going to keep going though. All's well. Oh, there we go, and there we go. So that's 3/8 my hole. I'm going to see if I can pass all my wires through. Actually don't know that I will be able to, but we're going to check and see. I'm just going to do one at a time. Probably be easier to get them all through. Do one at a time. I want to make sure I don't rip off my labels accidentally. And here. Pull that label up. I'll pass it through. Same thing here. Pull the label up. And just pass it through. Yeah, 3/8 will work. So, down to that third rung on our drill. Honestly, probably could have done, no, 3/8 was probably fine. Okay, so I have, again, my cable management done. I have kind of these wires tucked in the sides here. I have my red tucked in, and we are going to go ahead and slide this back to here. And, well, not yet. We're actually going to slide the bottom part on first, our base, for our outlet. Forgot about that. So let's slide that back on. Right there, and then now I'm going to go take this part and I'm going to screw in the sides here. Those little corners, switching out the drill bit first. And let's start with this side since it wants to keep popping out. Take those screws and slip them back into place. Uh-oh. A little off. Me rushing doesn't help. I don't want to strip that screw, so I may switch over to a different bit. Actually going to just try to get the rest of those in. Best I can. There we go. That one. And this one. And remember, we had two on the other side with the cord that we took out, so I'm going to go ahead and do those. Okay. And we got one more here. And I got a stubborn one over here still. I'm going to back him out and then go to the other side and try to get going better here. It does not like it, but we got it. And then I don't know where the other screw went, but I would have put it right here. And we finished. So we're going to take this and place it inside of our plastic box with the other electronics and go from there.